The Burning Ship Fractal is even more striking than the Mandelbrot set, with its towering, flame-like structures that resemble a ship engulfed in fire. It's a chaotic variation of the Mandelbrot set, not because of how it looks, but because of the chaotic behavior of its points. Before moving further, please subscribe for more videos like this. In the Mandelbrot set, we square complex numbers and add a fixed complex point in each iteration. I explained it in my previous video, but in Burning Ship Fractal, we follow a more chaotic approach. Here, points escape the limit quickly like this. Instead of directly squaring the complex number, we first separate its real and imaginary parts. Now, on each iteration, for the zx part, we find the difference between the square of the real and imaginary part plus the real part of the fixed complex point. This will stretch points on the plane. For example, if we move this red point, all these points derived using this formula will stretch exponentially. Now, to calculate zy, we take the imaginary part of the complex constant and add it to twice the product of zx and zy using absolute values. The product of zx and zy controls how strongly the point moves vertically. When both values are moderate or large, the movement is stronger. But if either zx or zy is close to 0, the vertical movement becomes very small. And then we check if the magnitude of this point is below the limit or not. If it's above limit, then we just break the iteration. Let's code this in C. So this update pixmap function renders fractal in the pixmap buffer. We first generate x and y axis points of the plane. This is basically an equivalent of line space from Python. X start is the starting point and X stop is the ending point of X axis. Width is 800, so we need 800 points in between starting and ending. To calculate the step of each point, we find the length of the axis and divide it with how many points we want. Now just add this step to the previous point of the axis. You will get an axis of 800 points with linear distribution. Now we go through each pixel from pixmap, convert it into a complex point. We then initialize zx and zy with 0. Now on each iteration, calculate new values of zx and zy. Set pixel to default color. Now, if the magnitude of the point zx and zy goes out of the limit, color that pixel based on the iteration at which it diverged, and then break the loop. Now, for the zooming part, we first store coordinates at where the client clicked on the window. We convert this coordinate into points on the x and y axis. Set zoom factor, which means how much we want to zoom in. Calculate new length of x and y axis. Now calculate new start x, stop y, and stop y. This will be the new zoomed plane with a new x and y axis, and that's it. Now let's compile this and see what we get. This doesn't look interesting. But if you zoom in, you will start seeing this ship-like structure which is burning in flames. It's so cool, right? And if you keep zooming in, you will find more interesting variation of this burning ship. But before leaving, please don't forget to subscribe my channel. Till then, bye-bye.